Hello, makers! This video is brought to you by the Creation Station at the La Quinta City Library. Check us out on social media. William here with you today. Here at the La Quinta Creation Station, we've put together a small pen plotter. It's constructed out of 3D printed parts and common components. This pen plotter's design is from the user Henryarnold on the popular printing model repository Thingiverse, although it is a remix of other popular designs which precede it. Watch or follow along in this short series of videos and we'll show you how we set it all up. In this first video, we'll list the materials and put the hardware together. For the most part, we'll be following the documentation for this design provided by Thingiverse user Jonathan K. This project involves the use of potentially dangerous materials or equipment. Please don't cut yourself, or burn yourself, or pinch yourself. Here's our list of materials. You'll need PLA filament and a 3D printer to print stuff. NEMA 17 stepper motors and toothed gears. M8 linear rods, 450 millimeters in length. M8 linear rods, 350 millimeters in length. M3 linear rods, 75 millimeters in length. An M8 threaded rod, 480 millimeters in length. LM8UU bearings. SG90 servo. Springs from a ballpoint pen. 2 meters of GT2 belt. An Arduino Uno. The popular Arduino CNC shield. Stepper motor drivers. Jumpers. A 12-volt power supply with at least 2 amps of current capacity. For nuts, you'll need M3 by 0.5 millimeter, M4 by 0.7 millimeters, and some nuts for whichever threaded rod you picked. For screws, you'll need some M2 short screws. You'll need M3 by 0.5 millimeter by 20 millimeters, M3 by 0.5 millimeter by 16 millimeters, M3 by 0.5 millimeter by 6 millimeters, M4 by 0.7 millimeters by 35 millimeters, and you'll need a hex head, M3, 0.5 millimeter by 20 millimeters. You'll need some screwdrivers and Allen wrenches, some cutting tools, some nut wrenches, and a multimeter. The first thing for us to do is to go to the Thingiverse page and grab the PDF with the instructions. We'll be following along as we go. The first step in the instructions is to 3D print all of the 3D printed parts. In the project's description, the author says that there is an even better pen holder in the remix section than the one that he offered us, so we'll start by going ahead and grabbing that. We'll click on the remix page. We'll scroll all the way down. Or we'll find the thing. We'll click on the link. We'll go to its file page and we'll download the appropriate file. We printed everything in PLA with 70% infill, a 0.2 millimeter layer height, and a cuboid infill pattern. These are the parts you're going to need to print from the Thingiverse page. Grab the part named X support L and the two 450mm rods. Insert the ends of the two rods into the two 8mm holes on the support piece. Gather the threaded rod and some nuts and washers that go along with it. Thread one of the nuts 1 to 2 inches deep onto one of the ends of the rods and insert a washer. Insert the new short end of the threaded rod into the support piece up until it hits the washer. On the side of the threaded rod, which now pokes out from the other side of the support, add another washer and tighten it all together with another nut until it's all finger tight. Gather both of the clamshell parts and the LM8UU bearings. Press the bearings into the grooves, which should be printed out to be pretty well shaped and fit for those bearings. You can use your thumbs, you might use some pliers, you might use a mallet, but kind of get them in there without breaking the plastic. Gather your printed spacers, some M3.5 nuts and M4 nuts, and the rotational bearings. On the bottom of your bottom clamshell part, you will find a lot of holes for nuts. In the center we'll put the M3 nuts, and on the outside edge we'll put the M4 nuts. Use the printed spacers to offset the bearings from the clamshell, and screw them in with M3 by 35mm screws. Slide the bottom clamshell onto our previously partially assembled axis. Make sure it can slide around pretty well. Repeat the threaded rod steps from earlier on the other end of the threaded rod, adding a nut and washer. Fit the other support piece onto the partially assembled axis, making sure the rods go in the appropriate spots. Add a nut and washer to the other end of the threaded rod. Gather M3 by 5 nuts and M3 by 5 by 16mm screws. Insert the nuts into these slots and insert the screw into the hole on top, screwing it through the nut. These will act as set screws and help to keep the rods in place. Now gather the stepper motors and the toothed gears which go on top of them. Insert the toothed gear onto the shaft of the stepper motor and tighten the grub screws with an Allen wrench. You may find later that you have to adjust the height of these pulleys, so be prepared to do that. Grab your partially assembled axis and insert the stepper motors into the intended holes on the left and right support pieces. Carefully flip the whole assembly over and screw the stepper motors in using the M3 by half by 6mm screws. Flip the assembly back over when you're done. Next, we're going to be assembling the clamshell. This is the position the spacers will go in the final assembly, but it will be easier to put them on the bottom clamshell instead of the top. Place the spacers in the four corners above the holes, place the top clamshell on top, and screw them all together with the M4 by 35mm screws. Gather the Y front and Y back parts and the two 350mm rods. Insert the rods into the 8mm holes intended on the piece Y back. Now that the rods have been inserted, we will take some M3 nuts and stick it into the set screw slots as before, and a 16mm M3 screws to tighten the rods in. We'll also take an M4 nut and stick it into this slot right here, and a bearing and stick it in the middle groove there. And we'll use an M4 screw to hold the bearing in place and allow it to spin freely in the middle there. Put the carriage in the middle of our previously assembled axis and slide our new axis onto the bearings, which will run perpendicularly to the previous axis. Now we're going to insert Y front onto the linear rods, but we need to make sure that the orientation is correct. The tab part should be facing the sky, and it should be facing towards the machine, as pictured. Once again, we have a spot for some set screws, so we're going to add M3 nuts to these slots, and we're going to screw them in, as always, with our M3 by 16mm screws. When we bought the belt for our project here, we bought 5 meters of belt, as it was more convenient, so we're going to cut this down to 2 meters of belt. 2 meters is equal to 78.74 inches. We found you could probably round that down to 75 if you prefer. Now we've got to feed the belt through the machine. Secure one end of the belt to Y front, somehow, a binder clip might help, and then run it through the machine, sort of following the pattern on the screen. You're going to want to make sure that the flat end of the belt is pretty much always touching the bearings, and that the toothed end of the belt is freely floating in the air, except for when it goes across the pulleys, the toothed pulleys. So you kind of just string it through and under and all around, and you might need some pliers to help you get it through there, but other than that, it's not too bad. The tooth part of the belt will slide across the pulley in Y back, so don't really worry about it. It goes in through the inside, out around the outside, in through the inside, out around the outside, and so on, until you get all the way to the front again, where you will want to hold the end of the belt and the Y front part. There are some little teeth on Y front that you can use to hold the belt temporarily. Once you put the belt in, the axes should not move super freely anymore. On the back of Y front, we will find 3 grooves for M3 nuts. We should go ahead and insert M3 nuts into those grooves. Gather the part base slide heavy duty and some M3 by 16mm nuts. We're going to use the base slide part to clamp the belt into Y front. Be sure to keep the belts as tight as you can while you do this, and it is very helpful to screw one side of the base slide part in to hold the belts taut before you do the other side, as you will run out of hands if you don't. Here you can see the belt taut and clamped down, and in that square bracket up top we're going to insert the servo, this servo right here. Insert the servo into the hole for it and screw it in with 2 M2 screws. Also, the servo arm should be inserted now and oriented in a way sort of like you see depicted on screen. Grab the pen holder, M3 rods, and some springs, because we're going to put all that stuff together now. The rods will run through the base slide, the pen holder, and then back into the base slide, coupling the 2 parts together and giving the pen holder an axis to slide upon. The tricky part is that we need to place the springs along those little linear rods in such a way as they put pressure against the pen holder, pushing it against the servo, so that when the servo goes up, it pushes against the springs, and when the servo goes down, the springs will naturally put the pen holder back down onto the paper, sort of as depicted right there, in a clumsy way. It helps a lot to insert both rods all the way through, and then pull one rod out until you can put the spring on, and then push it back in all the way, and then repeat for the other side. We are more or less done with constructing the device, but we need to walk around the machine and tighten up all of the set screws, and to be sure to tighten up the nuts on the threaded rod so that the whole structure is fairly stable. In the next video, we're going to cover plugging all of the motors into the Arduino and the CNC board, getting some of the software set up, and getting all of the motors moving in the right directions. Hope to see you then. Thanks for joining us, and if you're in the La Quinta area, give us a call and check us out. We got some cool stuff over here. Goodbye, and have a nice day.